Parallel and perpendicular through point. What is an equation of the line that passes through the point 1, 6 and is perpendicular to the line x plus 3y equals 27? So again, we'll start off with the basics. When they say equation, they want this in slope-intercept form, which is y equals mx plus b. B is our y-intercept, where we often, when we have to graph, we begin with our y-intercept, and then we move with our slope or our m value. So again, our ultimate goal is when it's done, it's y equals mx plus b form. Continuing on, they ask us, they give us this point right here. They give us the point 1, 6, and we'll use that in a bit, but they change it and they said that it has to be perpendicular. So perpendicular is a little bit harder than parallel because you actually have to do things. So first of all, let's go ahead and write this down. Okay, so there's two things when you're talking about perpendicular. In regards to slope, we're talking first of all opposites. So if you had a positive slope, your perpendicular would be negative. If you have a negative slope, obviously it would be a positive. So we describe that as being opposites. So the first thing is whatever our slope ends up being, we have to make it the opposite. And then after you make it the opposite, you have to go ahead and use the reciprocal. Reciprocal. Hopefully I spelled that right. Yeah, I'm pretty sure. Okay, so perpendicular is an opposite reciprocal, and a reciprocal is a fancy way of saying it. You're going to take a fraction or an integer, and you're simply going to flip it upside down. So again, opposite, positive, negative, reciprocal, flip a fraction. So just like we did in the last one, we actually had to go ahead and take this equation right here, and we had to change this to slope-intercept form so we can steal the slope or the perpendicular slope. So I'm just going to move it over here. I'm going to rewrite it as x plus 3y is equal to 27. And then to isolate my y term, I'll begin by subtracting x on both sides. And then I would have 3y is equal to negative x plus 27. And then I'll get rid of the coefficient by dividing by 3 on each side. And just like I did in the last one, I often divide the x and the constant term by different 3's. So I usually, instead of writing one big fraction in one denominator, often your b value will simplify. Okay, so we can put a 1 here. So this is really negative 1 over 3x. And then 27 divided by 3, that's going to give us 9. And we do all that work because what I need to do now is I need to go ahead and steal the slope. So my slope is negative 1 over 3. In the last one, if it was parallel, I would just use negative 1 over 3. But in this case, it's perpendicular. So this kind of capital T that's been inverted stands for perpendicular. And our perpendicular m, well, that one's negative. So ours has to be positive. And then the reciprocal of 1 over 3 is 3 or 3 over 1. But honestly, I would prefer to use just 3. It's a lot easier than using a fraction. So our perpendicular m is 3. Okay, so now we have our slope. Now we're going to have to go ahead and we're going to have to take our point. And our point is 1, 6. So let's switch over to slope-intercept form. Y equals mx plus b. And we're going to substitute 1 for x and 6 for y. So here we go. 6 is equal to, our m was 3, which is nice. That's easier than a fraction. Our x value is 1 plus b. So this will simplify to 6 is equal to 3, because 3 and 1 would just be 3, right? 3 times 1. And then we'll subtract 3 on each side. And 6 minus 3 is 3. And then 3 is equal to b. Okay, so let me go ahead and point out that my b value right here is 3. And then our m value is 3. And they're exactly the same, and I guess that's okay. I just didn't think they'd be the same. All right, cool. So I have y is equal to 3x plus 3, and we'll box that and we'll move on. Now, before we go on, I want to caution you, out of the two, perpendicular is the most difficult for kids because you have to deal with opposite and reciprocal. And a lot of times kids will do the opposite, they'll forget the reciprocal, or they'll do the reciprocal and they'll do the opposite. Oh, you know what? In closing, I guess there's one other hint I could give you. If you mess up with doing the perpendicular slope, here's how you can check it, just to make sure that you use the correct slope. So if you want to check a perpendicular M, just take the two different slopes. So our first slope was negative 3 over 1. So I'm just going to write negative 1 over 3. And what we're going to do is we're going to multiply that slope by the second slope we got, which is 3 or 3 over 1, whichever one you want to put. And when you multiply them, when you multiply them you get negative 1, you did it correct. So watch this. Negative 1/3 times 3 over 1 would first give me negative 3 over positive 3. And then notice negative 3 divided by positive 3 is negative 1. So that, when we get negative 1 when we multiply our slopes, that confirms that we got the correct slope. So that might be a way to avoid messing up the opposite reciprocal by multiplying your two slopes together to make sure you get negative 1. Again, this is not necessary. This is just a check, just a strategy to make sure you're doing it correctly. And I hope you found this helpful.